Good afternoon, everyone. Thank you very much for being here and for reserving us some of your time. Let me introduce the speaker of today, Professor Chmielewski. First of all, thank you very much for accepting our invitation. Professor Chmielewski trained in chemistry and chemical engineering at the Warsaw University of Technology. He started working at the Institute of Nuclear Chemistry and Technology, first as head of the Department of Nuclear Methods of Process Engineering, then as scientific director of the Institute, and finally as general director of the Institute that has been nominated by the International Atomic Energy Agency as the collaborating center for the period 2010-2024. He was appointed professor in 1992, and in his long career, he had a lot of experience as an expert lecturer at different universities all around the world. University of Tennessee, at the University of São Paulo, Brazil, in Saudi Arabia, in Japan, and also in Italy, at the University School for Advanced Studies, within the master degree in nuclear and ionizing radiation technologies. He served as a technical officer at the International Atomic Energy Agency and as member of several commissions, scientific councils, academy, advisory teams at national and international level in the energy and nuclear energy areas. He is currently a board member and director of the International Radiation Association, and he is the editor-in-chief of the scientific journal Nucleonica. Of course, he was involved in the development of several European and national projects, author of over 150 papers and books, and 65 international patents, many of them implemented in industry. So, as you can understand, Professor Chmielewski is an outstanding scientist that brought relevant contribution in the radiation chemistry and technology field. So now I would like to give the floor to Professor Chmielewski for his presentation. Thank you.
And from that you may learn how radiochemistry and radiation chemistry is very important. Just recently, also here in Poland, our government decided to build new blocks for nuclear energy. As a matter of fact, our cooperation with Kasatia start many years back also on nuclear energy development in Italy. So maybe also someday Italy also will join this program. But today I will talk rather about the application of radiation chemistry in the environmental protection, because this is very important issue, and also we as radiation or radiochemistry people may contribute to this help. You know that nowadays, unfortunately, we have a big air pollution. There is emission of SO2 and NOx, CO2, and also the different particulate, organic carbons. Therefore, we have to do something with that. Our atmosphere, if you look on Earth, if we just downscale the Earth to the size of apple, we are living just in the skin of this apple. That means that we have to protect very much our atmosphere. Even we are paying for water, but we are not paying for oxygen, for air. But anyway, this is very important issue. Everybody knows about that. And there are different problems concerning the emission of different SO2 and NOx pollutants, also PM2.5. So also this, which was first observed in Germany, so-called acidic rain, which destroyed the forest. Nowadays, very important is this greenhouse effect. And somebody is saying, I do not believe that there is such effect, that such effect exists. But we chemists, we know the answer, because we know that all the molecules in which we have more than 2 atoms, they absorb infrared radiation, and temperature of globe is just rising. So here in the application of this our gas electron beam irradiation of the gas using the electron accelerators, we concentrate on the removal of SO2 and NOx. So as you see here from this, let's say, scheme, that when we irradiate the air with electron beam, but also it can be corona discharge or other plasma methods, non-equilibrium plasma is formed. And later on, of course, you are getting a lot of different ions and also active species, which electrons as well, which later on may run different processes. And on this basis, so you have different, let's say, excitation of different molecules. And you have to remember that, of course, the molecule has different types of energy. So in principle, we are interested in energy which goes to the reaction, because other types of energy like rotation or kinetic energy just making the gas more hot. So that this way, when we are getting these different free radicals, ions, etc., and we add, for example, ammonia, we are getting very fast reaction, and later on we are getting some byproduct if we are looking for the removal of NOx, which is not easy. That means that we may get oxidation of NO, and later on getting nitric acid, which with reaction with ammonia is giving ammonia nitrate, and this is very good fertilizer. Concerning SO2, these are the also so-called radiothermal reactions, that means done by the ionizing radiation. So in this case, very important is this OH radical, which is formed from the water vapor, which make oxidation, and finally we go to the sulfuric acid, and finally we are finishing with ammonium sulfate. Therefore, we are getting mixture of the ammonium sulfate and ammonium nitrate, which is good fertilizer. Such installation is done this way, that we have of course the boiler. This is called boiler, and later on the flue gases go after changing temperature to the temperature about 70 centigrade. It goes to the reaction chamber where we are using the accelerators, and later on at the end we have ESP just to collect solid product. That means that we remove pollutants, but also we are producing fertilizer, and this is just this green technology, zero waste technology, or recirculation, this economy, circular economy, because this way the waste is becoming good product. So after this pilot plant, which was presented there, the big industrial plant has been built, in which the power of accelerators was 1.2 megawatt. Here you see the scanning of the electron beam inside of the reactor. If we have this beam with energy about 700 keV, the penetration is about 4 meters in air and gas, and therefore this is just irradiation of the whole cross-section and the good efficiency of removal of both pollutants. So on this basis, it was possible to find out that SO2 is removed more than 90%, NOx is lower because the consumption of energy for NOx is much more bigger. Therefore, of course, we are getting also the effect being below standards by applying of the combination of low NOx burner and also this technology. It goes to the concentration below the environmental standards. And this is the important that in one stage we are removing both SO2 and NOx. Normally you have to apply two different conventional technology to remove one of this one of these pollutants. And on this basis is possible, as I just told before, is possible to get fertilizer, good fertilizer, very pure, high quality fertilizer. Another problem concerning this removal and using of electron beam is also the emission of so-called polyaromatic hydrocarbons. And for example, this benzoalpha-pyrin, even in Italy, there is, of course, gas mostly using, natural gas mostly using for power production. Also in Italy, some people, they have this fireplace where are using wood. Also here you have to be very careful because the flame itself is very good plasma reactor. So even these all compounds which you see here do not exist in the wood. They are just formed during the combustion process. And this benzoalpha-pyrin is very terrible compound because exactly the dimensions of this benzoalpha-pyrin are the same as dimension between these two chains of DNA. So this benzoalpha-pyrin quite easily incorporate in the DNA and later on, of course, make some different, let's say, changes in our organisms and even cancer. But of course, this is the reason that DNA, these two chains are connected by hydrogen bonding. So also chemists know that this is very low energy bonding and very easy to be destroyed and replaced by other bondings. Now, of course, this removal also concerns different chlorinated hydrocarbons. As you know, in the case of the municipal waste, the problem of the dioxin emissions. So also the Japanese colleagues were studying this removal of dioxins with use of electron beam, and also they got good results to treat this type of the gases from incinerator. Here, if somebody has contact with agency, is my friend Dr. Bum-Soo Han, who is now working in agency, and together with our Korean colleagues, we just built the pilot plant for the off-gases treatment in the Aramco company in Saudi Arabia. It is the previous example concerned the coal combustion. This one concerned combustion of oil. Also in this case, the results were very positive. So this is the scheme, and it was interesting that for study we were using mobile accelerator, which was installed on the trailer and can be moved from one place to the other just to check possibility of application of the technology. Nowadays, you don't believe, but the biggest emission of sulfur dioxide and nitrogen oxide is higher from the ship than from the stationary sources like power station. So here we had and still have interesting talks with Grimaldi company, also Italian Safeguard. We had very interesting meeting in Genoa, how to treat this different of gases. As you see from here, the big ship or the personal carriers are using high power two-stroke diesels, 80, 100 megawatt. That means that's like small power station. and unfortunately the emission of the these different pollutants is also very high. Therefore, around the world, you see here that in some regions it's possible to see that this emission is very, very high, and therefore also the some regions like Baltic Sea, they are so-called emission control areas, also around the United States, but also very soon Mediterranean Sea. Also this will be just necessary by the ship owners just to make and apply this kind of the different removal SO2, NOx, and VOC removal technologies. And as we are talking about the chemistry, chemistry is everywhere. So in this case of cleaning off gases from the ship, from the diesel, we just observed that there, unfortunately, there are some back reactions. That means that we want to oxidize our NO because 95% of so-called NOx from the combustion is emitted of the in the form on nitrogen oxide. Nitrogen oxide is not reactive and also not soluble even in the water, so we have to oxidize it to dioxide, nitrogen dioxide. But unfortunately, there are also back reactions that we are getting, like here, back reactions that we are getting again NO. So as we, this kind of reactions are which we need for our technology just to get acid, which later on is scrubbed by the water. But in this case, of course, as chemists know, we have to remove the products of oxidation, So if we remove this byproduct of oxidation by some water scrubbing, later on our equilibrium moved in the direction of product formation, not back. So this is one way how to get better efficiency of removal of something, or better production efficiency, that you are removing from the reaction zone your product. And this is how we apply that. And therefore this product, our technology is just hybrid technology, accelerator, and later on there is just scrubber for the removal of this acidic pollutants. And as you see here, this is the test which we perform under the project ARIES, which was just run by the CERN in Switzerland. Maurizio Wertener, the Italian professor, was in charge of this from the side of the CERN, and also the Technical University in Riga were involved, and Fraunhofer Institute from Germany, from Dresden, just provided low energy accelerator. So we were able to show that this technology is working. So this is the final scheme of the process which was applied. Next problem is, it is water. We have water shortage all over the world, so as a matter of fact, we should use this wastewater again and again, and also application of electron beam may lead to the removal of harmful organic pollutants by we are getting radiolysis of water. The solvated electron is reductive, also hydrogen ion is reductive, oxygen, the hydroxide radical is just oxidizing. So this way we got complete the composition, or by removal of toxic group. It's much easier to be treated by biological treatment. In principle here in wastewater and sludge from municipal wastewater treatment plant, we have two different chemistry segments. One is the process chemistry connected with water radiolysis, so we are getting here different products which later on react with these pollutants, or for the pathogens, we are using this, that radiation directly or indirectly may destroy DNA in different pathogenic bacteria, but also parasites, because these are often present in the wastewater. So, of course, in the case of the electron beam irradiation, we may compare somehow with this UV radiation. You know also that UV can be used for the treatment of water. However, as this is connected with the light band, that means that also you are getting just absorption if the water is not very clean, if you have solid. This is not a problem in case of the radiation, ionizing radiation, but also it's good to apply beside of the electron beam from accelerator ozone, because this way you may just get this all environment with the OH radicals, which are just oxidizing radicals. So you are get rid of this type of radicals, just solvated electron and also hydrogen, and instead of that you are getting the full content of OH radicals for oxidation of the organic pollutant. So this way the efficiency is even bigger. We tested this technology in our case for the ballast water discharge. You know that ships going somewhere with the cargo later on are coming back sometimes empty, just with the ballast water. But if ballast water is just taken in very hot regions, then you are getting, different types of the microbes like here. But these microbes have to be just destroyed. So this was our work done, that we applied, beside of the filtration, we applied the electron beam just to keep this ballast water safe, and in such case ballast water can be discharged without problem, but also used for the technological reasons. So this is the severity of water shortage all over the world, and we have to apply this technology. So that means that the most important is treatment of the municipal waste. So this is treatment of municipal waste, and this is a very good biological treatment with active different flocks, biological flags. But later on, you are getting just this biological sludge is growing because it's eating this, let's say, different organic pollutants. Therefore, somehow it has to be used. It is used for the biogas treatment. Many years back, it was the sludge disposal landfilling, but no more allowed. You have to just combust it, but combust is crazy, because if you have 3% of solid and 97% of water, nobody may put water on fire, so first you have to dry. But on the other hand, this is very good fertilizer, which can be used again, because it is organic fertilizer and also has about 2% of phosphorus. Therefore, the best way is to make some kind of treatment of the water. So this is one, that we are just reclaiming the water for the further use, and this is the wastewater treatment plant built in Korea for the textile wastewater treatment. This is just recently built wastewater treatment plant in China, where they are using this water again. So that means that this way they may save about 4.5 million tons of water annually. So this is very, very big achievement. And this technology, in my opinion, has a great future. On the other hand, this biological sludge, there are some pathogens inside this type of pathogens. These are human or animal pathogens. But later on, if you want to use this for the agriculture, the parasites and eggs of parasites has to be destroyed to the zero, no presence at all. So this way, we also in India already there are 2 plants which are using gamma sources for the hygienization of the sludge and production of the fertilizer. Here in Poland, we were testing this process with use of the electron accelerators, and we found that with the dose about, let's say, 3 kilograms, we may destroy all these different microbes, and that means 3 kilograms is something like 3 kilojoules per kilogram. This is energy consumption from this ionizing radiation, and therefore, but also additionally, we may destroy different organic compounds. Diclofenac is the commonly used non-steroidal drug, and this drug is consumed by the people, and later on, of course, is also what was left after using by our body is with urine goes to the water, and later on it is in wastewater, which later on is purified if we take the water from the river and later on used as a water. So this what we just proposed, and tests were done. We proposed hybrid biogas electron beam system, and this way we are producing biogas, and this biogas is producing electricity to run the accelerator, but on the other hand, also accelerator allows to produce very good organic fertilizer after hygienization and getting rid of this different parasite and bacteria. This is funding projects, and thank you very much for your attention. I was asked by Elena just to be shorter than half an hour, so I just followed her orders. Thank you very much. This is all what I wanted to say today. Thank you.
Thank you very much, Professor Chmielewski, for this interesting presentation. And I think that for the younger people who are connected in this moment, I think it's the first time they heard about the use of radiation for so many purposes, all aiming at solve some problems that are very important for our society in these days. So I would like to invite the audience to open the microphone, or use the chat if they prefer, and ask a question to Professor Chmielewski, or if they have comments or curiosity. So don't be shy, open the microphone and ask.
Yeah, what I may add to my presentation, just to just attract people, because here I was talking about the environmental protection, but the electron beam and gamma sources, even I've been in Italy, so we have also such station in Bologna, for example, just for the sterilization. Yeah. Nowadays, widely is used for sterilization. So in principle, most of the products which you are using for the blood testing or something, some wound dressing are done by irradiation. Also, I may say that now our ladies scientists got very nice project with Clelia Dispenza from University of Palermo, just to go. They won the place number 1 in the call. So really, this is fantastic project. Also, the Italian companies, also Portugal is involved, Sweden, UK. So that means that what I was talking about, this is kind of the international action, and also it would be nice if somebody sees something interesting. We are open for contacts and discussions. And now I am waiting if there are any questions.
I can start with some comments. First, listening you and your presentation, I think my first thought was that your deep knowledge about radiation chemistry and chemistry, of course, enable you to develop this kind of system, very, very effective in solving a specific technological problem. And I think that is important also for the youngest to understand that to have a strong education and preparation in technical and scientific preparation is paramount in order to be able to develop something that could be relevant in order to achieve goals or to solve problems, technical problems.
Yeah, you are right, because of course there was no time to go in details, but in each point I was showing what is the basis of the process, yeah. So all are connected with chemistry. For example, this VOC also I showed that in some cases is quite complicated chemistry. So for example, if we are thinking about the plasma, the destruction of toluene, for example, you have to use something like about 85 different equations and consider about, let's say, 74 different 285 equation and 74 different type of the species, chemical species, active species. So everywhere is chemistry. Also, I would add to that, so chemistry is under the beam. We have to understand what is the chemistry of the process, and therefore we know what doses and what kind of the treatment we should apply. Later on, of course, chemical engineering also is important, because in all this, you know, the let's say type of installation, you see the components, reactors, but also some processes like the removal of the byproduct in SP, back filter, etc. So that means that this is important. Of course, we need also the people who knows how to construct accelerators. Of course, there are companies which just provide accelerators, but you are right that knowledge is the first, and later on you may know how to use it.
And we can't work alone, but these are multidisciplinary matters, so we need to work together.
That's exactly it is, yeah.
You showed the situation about the water shortage in the next future. So do you believe that the technology you suggest, so based on electron beam, could give a tangible contribution to slow down, maybe we can say solve, but in case slow down this situation?
Yes, I think even also here, just referring, I have one colleague, Andrea from Bologna, so we were trying with different groups also apply for the project with European Union, because, you know, in the case of the environmental application, first you have to have standards. No, because, you know, no company is going to put money if they don't have to put money, yeah? So first, for example, nowadays, there is European Union directive, yeah? So it says you may use your sludge from the municipal wastewater, but it should be treated. It should be treated. So at this moment, it is really, this first directive came about 2002 or something like that. So before, nobody was thinking about that. Nowadays, they know what they have to do, something, yeah. Because of course, there are also some conventional processes, but anyway, idea is just to treat it. Secondly, circular economy. We know Europe says not waste your resources, yeah. So also it fits well with that. So I think that wastewater treatment and also this sludge treatment, especially, is because, you know, in 20th century we learned that we will apply the artificial chemical fertilizers, yeah. But you remember that before that our grandparents were using organic fertilizer. So if you are using only chemical fertilizer, you deplete your soil with this organic humus, which is very important, yeah. So there are different things, and I think that some technologies are new. They need some new development. So I think your students is the group which may just in the future form some kind of the policy, but not only policy from the journals, but also from the science as well. Yeah, just what to do.
Yeah, you're right. Instead, concerning the plan to treat the emission from the engines of ships,
yeah,
I ever never think about that. I have to admit this. And do you think that do you foresee a wide diffusion of this kind of plant? Is it feasible from an economical point of view?
That's right. Yes, you know that even in Italy there is company EcoScrap. I don't remember well, but it's already providing you scrubbing units. But you have to use separate unit for the NOx. In this case, you are using so-called non-catalytic reduction. So you are just injection ammonia or urea, which later on form ammonia. And this way you are just changing nitrogen oxide to the atmospheric nitrogen. It's okay. But the second scrubber is the scrubber for the SO2 removal. So this is also nowadays installed on the ships. We have the collaboration with this our shipyard in Gdańsk. So I have seen big Swedish ferry on which they, inside of the chimney, which we see, they were using this scrubber for SO2 at the moment. So such installation cost, you know, something like $6 million or something like that. But they have to apply, because if such ship without the treatment, even we were talking to Grimaldi, not all ships were sent to the US, because if you are entering waters of US and you have no the emission treatment systems, you pay each day $20,000 fines. Yeah? Yeah. So that means that also in the case of Italian, this coast guards, we were just in their headquarters. It looks this way, that if your ship is coming to your port, in most cases they are giving the cable to the ship just to stop engine and discharge from the land. But I ask also how they control this emission. But they say they have some special company, but they may request even the ship on the open sea that they come, because they are not people to measure, yeah, but they are bringing these people and they are checking if the, let's say, this emission is in agreement with that, because each captain, it has some kind of books, yeah, and in these books you have to just declare, I don't emit SO2 or different things, yeah. So this is very seriously taken, yeah, and there are methods how to just get just work to relation to the standard. Yeah.
Yeah. is always even greater attention to this, to check.
That's
so
right.
they
That's
need to,
right.
to
Yes,
answer to this.
that's right. That's
Okay.
right. That's right.
Thank you. There are other questions from the audience. If someone would ask something or write in the chat.
But I think that yeah, there is something on chat or not? No. So of course everybody knows, my presentation, which just it was recorded, so you have my email. If somebody is interested, we may send some materials. There are many publications, etc. So this was the lecture.
They can see the webinar, the recording of the webinar, or in case they can send us a question by mail, for example, and I can send them to Professor Chmielewski, and of course.
No, yeah, I may add also that we have this Erasmus program, and we have person who is in charge. So even 3 or 4 years back, we had just training for something like 40 students from all the country, also from Italy, and 2 weeks in Warsaw, 2 weeks later on after some time in France, in Palermo 2 weeks, and in Latvia, and they were getting this 8 ETS points, just for this study, so it was accepted according to the Bologna Agreement.
Yes. Well, this is a very nice opportunity for the students.
So also Erasmus, you are welcome if some students are interested. They may contact us and we may find out if there is possible to get such exchange as well.
Good. And may I ask a last general question about the fact that your institution is a collaborating IAEA center for IAEA. So could you briefly explain what your institute do as collaborating center?
Yeah. So mostly, for example, this month we will have something like 4 or 6 different persons from Africa. This time, I mean, 1 person from Mongolia and 5 persons from Africa countries. So in our case, we just accept different fellows. Agency may send different fellows, and later on also we have involved in organization of so-called regional training courses that some people from different countries may apply and come to our institute there is course, something like that. No, and of course, nowadays we have also together with this agency project, so-called Eurolab, that we have money. If somebody wants to come to us, make some experiments on our accelerators, we'll get travel money, per diems, and also some money for materials. But it goes this way, that the scientist or group of scientists has to apply to this project, and later on, if accepted, it gives this opportunity. For example, also from Professor Clelia Dispenza, she and her student, they had no chance to irradiate some samples, so they are sending these samples to us. We are making this irradiation and sending them back. So mostly somehow I may just answer that also our people sometimes go somewhere as experts, just to help to establish some facility, to advise somebody on that, So I may say that in general there are different ways of the knowledge and technology transfer. And of course what you were asking me about this lecture is one of also action which I may say that thanks to you also this our function was somehow fulfilled, yeah, because this is promotion of radiation technologies.
Yeah, and let the people, and in particular the young people, that there are big opportunities to form ourselves by sharing, for example, other institutions, other facilities, to meet people and share the knowledge
That's
we
right.
can acquire, of course, with the sometimes with the right financial support that is necessary. We can't do without.
That's right. But I said, for example, even in this European Union project, in some projects we may accept somebody and just finance their just visit and work with us. Yeah. So there are different. Erasmus also, as you know, is something like that. So there are some opportunities, yeah, for sure.
Okay. If there are no other questions, the audience, the chat, let me check. No.
Okay. So thank you very much.
No, we thank you for the availability and the
my
very
pleasure.
nice presentation, and I hope there will be another
opportunity.
Yes, in the future.
Of course.
Sure.
Always would be pleasure. Yeah. Thank you very much.
Thank you very much, Professor Chmielewski, and thank you to all the audience. And I just remember that you can check on the YouTube channel that there will be soon the recording of the webinar. And in case you have a question or you would like to discuss some point, some topic that we have heard today, write me and I share the question and the topic with Professor Chmielewski. Thank you very much.
Thank you very much to all who join us for this meeting. Thank you very much. Bye and see you.